So let's get started. My name is Keshav. I'm going to be teaching CS 798, Mathematical Foundations of Computer Networking. Today's class, I'm going to basically give an overview of the topic and some rules for how I'm going to run this course. And then we'll get started with the first topic in the second half of the class, which will be on linear algebra. Let me just go through the, okay. So just sort of practical details. It's Monday, Wednesday, Friday, 9 to 10:20. So it will be in this classroom until some point, and then at some point we're going to get transferred over to the new math building. There's a seat over there. And the new math building is M3, so it will be nice. I believe it's a nice classroom. This is a nice classroom that should be even better. And we'll start there probably in about a month and a half or so. I'll announce it when that happens. This course is a funny course. Funny because although it's a grad course, it's actually more or less an undergraduate course. And what I mean by that is two things. First, the material in this course assumes very little from you. It assumes you have basically first year undergraduate calculus. You remember some of your first year calculus, so very little, somewhat of calculus. And I assume that you don't know any linear algebra and you've forgotten most of your probability. And so we're going to cover all of those things. And then the main part of the course really is about information theory and control theory. But to get to that, you need all this background on matrices and linear algebra and on signal systems and transforms and on probability a little bit. And then only then can you understand information theory and control theory. So that's why I'm doing all this background material. So it's basically, as I said, targeted at those two topics. And it's also funny because I'm teaching it as I would teach an undergraduate class, okay, which means that there's going to be much more emphasis on, in fact, there's going to be all lectures. Most grad courses, as you'll see, especially the 700, 800 levels, are going to be classes where you're doing some reading research papers and you're doing projects. You won't be doing that here. This is all lectures and homework assignments. And in that sense, this is just to get you sort of a remedial course, if you will. This is all the stuff you need to know before you can do any kind of graduate work using control theory or information theory. If you're not planning to do control theory or information theory, and you just want to get up to speed on linear algebra and signal systems and transforms, then that's okay. That's where you'll be at, but that's the focus of this course. You will not be doing any research, you won't be doing any projects, and you won't be doing any paper reading. So in that sense, the undergrad course. The reason why it's a grad course is because of the history of this, where this course comes from. My background is in systems. I've been building systems for 20 plus years, and my students all work in building systems. But I like to build systems which have some math behind it, and so I've been doing math sort of research based on mathematical foundations for many years. And it's been a source of intense aggravation for me that my students come in without really knowing much math. The undergrad computer science students can get a degree without really knowing much about mathematics at all. And so about 4 years ago, I started writing a textbook, which was this is the title of the textbook, Mathematical Foundations of Computer Networking. And it was basically everything I wish my students knew. And I started writing it, I realized it's everything I wish I knew, because I didn't know much of this stuff either. So I didn't know any information theory when I started writing about information theory. I had studied control theory, but that was 21 years ago, and I'd forgotten much of it myself. So this book started out as something to teach students. It ended up being something to teach myself. And what I realized was that many students also seem to have the same holes that I had. They didn't know much either. I didn't know much either. So I've taught myself to the point where I can teach others. Basically, that's the point. I'm not an expert in these areas. I'm not expert in linear algebra. I'm not expert in control theory. I'm not expert in information theory. What I'm trying to do is to see, okay, I'm somebody who works in systems, who has taught himself as much as possible these other areas. So you're getting the perspective of somebody who is kind of new to the field and learning about it. So I'm basically at the same level that you are now, okay, or I was at the same level you are now some years ago or a couple of years ago. So I'm not an expert who's been working in control theory for 20 years. So all the basic things that you don't understand, I also didn't understand. So this whole book and this whole course is information theory for people who didn't know what it means, who are confused by the basic things, okay, because I got confused by the I can only understand simple things and I got confused by everything. So it's basically getting to the point where you don't need to know much, but you can get to a point where you can understand something at least. But what I mean is that, you know, if you've ever gone into the mountains, typically you have these foothills, and the foothills hide the mountains. You know, if you're standing on the plains, you see the foothills, you see, oh, those are tall mountains, but you're not. When you go to the top of the foothills, then you see the real mountains. So this course is not about the mountains. This course is about getting you to the top of the first foothill. So you're in the plains, you don't even know the mountains exist. Okay. With this, you'll get to the top of the first foothill, and then you can see, okay, there are mountains over there. We won't go to the mountains. It takes many years to go there, but at least you know where they are. And if you want to and you spend the time, you will get there, but you won't get there, you know, in this course. You'll get to the top of the foothills at least. So that's another way of thinking about it. So with that, I'm going to pause, and there's a seat over there in that corner if you want. Are there any questions about course, or, you know, if you decide this is not the course for you, you can leave now. It's okay. I don't know who you are. So I won't see you again. There's a joke, you know, there's this guy who goes to general's office in the army, and he says, oh, this army is terrible. You know, the general was not wearing uniform. This army is terrible, and, you know, this general we have, he's hopeless. He can't run the war. And the general gets really upset because he's talking about him. He says, do you know who I am? I'm General so-and-so. He says, whoops. He says, do you know who I am? He says, no. I says, so he runs away. Of course, you know, so in the same way, I don't know who you are. So if you leave now, you know, you'll miss a lot of good jokes, but you won't upset me. Okay, any questions about this? Yeah.
What are the requirements for auditing the course?
Requirements for auditing the course. Just show up for lectures, and, you know, yeah, that's basically it. Yeah. Anything else? Any other? Okay, so that was sort of roughly what it is. I'm going to now briefly explain what the 4 topics are. And so the 4 main topics are going to be are these: so linear algebra, and then signals, systems, transforms. I'm going to put this in parenthesis, probability, because I'm not sure how much time I have for that, and then information theory. Okay, so these are the 4 topics, and what I've done is usually I taught this course actually in 2008, and I'd written half the book by then, and so I taught like 5 things or 4 things: probability, statistics, game theory, queuing theory, and optimization. So I taught those 5 chapters in 2008, but that was a twice-a-week course, and actually it was in this room. I realized that I was running out of time, and so this time I've actually asked for 3 times a week, 1.5 hours, which is actually 50% more lecture time, which means I might be able to fit in probability, and if I can, I will, but I won't know, because I really have. And I'm kind of doing this for the first time, so I don't really know. As you have guessed by now, I haven't taught any of this material before, so you're all guinea pigs. And everything I'm saying is being recorded, so anybody who watches this knows that they're being exposed to this material for the first time. Nobody has used these chapters as a textbook before, so who knows, there may be bugs in it too. Okay, so these are the topics. And the objective, to be more precise, is sufficient familiarity with the concepts here so you can read papers that use this, or read, you know, books that use these concepts, but not enough familiarity that you can write papers using these concepts. So I don't expect you to go off and be able to write a paper using information theory just from the material in this course. But you have enough so that you can go read some more, learn some more, you should be able to do it. Okay, so for example, You'll understand what the concept of mutual information is, but if you want to use mutual information in your own paper, you need to do a bit more work. Same thing, if you'll understand what a fast Fourier transform is, or what a PID controller is, or what eigenvalue is. But if you want to use these concepts, you'll need to do some more work. So it's more of a, as I said, remedial or background. Sorry?
Those in the videos?
Beg your pardon?
Can we have?
The videos, yeah, I'll come to that in just a moment, yeah. There will be videos. Okay, so that was the material of the course and the objectives. So any questions about that? Okay. So the way this course works, I'll keep asking, are there any questions? And I'll explain how that works in just a minute. But let me go through my thing here. Some more practical considerations. There is a very important graph which goes like this. This is time on the x-axis, and the y-axis is attention. And there's actually human attention as opposed to canine attention, I guess. And it has a thing like this, and then there's a dotted break over here, and then it actually goes up like that, something like that, and then that's the end. So some of you I recognized from previous classes, so you've seen this graph before, so I'll explain it to you anyway. So actually when you start the class, you have the peak attention. You kind of have come out from the outside, this beautiful sunshine, alternatively there's a heavy blizzard, doesn't matter. Okay, right now it's sunshine, but December you'll be knee deep in snow. But anyway, your attention will decline essentially exponentially, okay, till about 20 minutes. At 20 minutes, roughly speaking, you're dead. I mean, you have no idea. Yeah. I could be talking about anything, and it's like just flowing over you like a wave of audio messages which have no meaning, just pure syntax, no semantics, right? It's just you're kind of happily zoned out. You're reviewing last night's TV serial or whatever it is, or this morning's breakfast, or lack of breakfast possibly. So that's a good time to take a break. Okay. And I will. Okay. And then what happens is that you come back here. You come back here to this peak attention, and then you get another 20 minutes of good attention span, and then this. But what happens is when you know that the class is going to end, suddenly you perk up. You kind of say, oh, class is going to end. This torture is going to end. I'm going to be able to go out again and enjoy the blizzard or sunshine, as the case may be. So your attention actually starts rising. So this is a very well-known curve. And so there's no point fighting it. You may as well use it. So the way the class is going to work is I'll start on time, and then that means on time, okay, which means you'll start at 9. And if you're coming here at 1 minute past 9, you'll miss 1 minute. Basically that's what it is, according to that clock. So that gives you a little bit of leeway because that clock is a few minutes fast, or slow actually. So it's been slow for 3 years at least, okay, and nobody's bothered fixing it. And I don't even know how to fix it. I don't plan to try. So you get a little bit of bonus grace period because I'll go by that clock. But we'll start on time. We'll have 20 minutes, and then there'll be a 5-minute break, and then there'll be another 20 minutes, and then there's a 5-minute break, and then there's going to be 30 minutes because I'm going to use this roughly 10 minutes of end of class thing, and that gives you a total of 70 minutes of instruction, 10 minutes of break. And I've been doing this for about 20 years, and I have to say it works. And second, it's not my idea. When I was a grad student, which actually was true, I was once young and I had hair even. My instructor was Professor of Computer Architecture, and he kind of showed us his graph, and he taught exactly in this way, and I liked it so much that I decided to use it for all my classes, and I've been doing this ever since. And many students have told me years later that they didn't like anything about the course, but at least they liked the breaks. So at least I did one thing right. So that's what we'll do. So these breaks are not necessarily breaks where you're sitting around, talking to each other. No, they're actually something happening. In the first break, I'll be doing a roll call. Okay, so This is an old-fashioned idea where I actually call out people's names and I figure out whether they're present or not. And the reason for the roll call is twofold. The first one and the most important one is this way I can know your names. Okay, my goal is that after 2 or 3 weeks, I should know everybody's names in the class. Okay, why do I need to do that? This is because when you're falling asleep, I need to wake you up. So I'll say, you there, you know, I hate to say you there blue shirt because you change your shirt. And next time you'll not be wearing a blue shirt anymore, so I can't call you blue shirt. I have to call you something. So better to call you by your actual name. So the roll call. So the way the roll call works, the first week will be painful because I want to know what your names are, and more importantly, I'll be mispronouncing them, probably terrible ways. You should not feel bad because nobody can pronounce my name either. And so you know, I feel perfectly happy mispronouncing other people's names because they did that to me. It's you know. But if I recognize you, then I won't call your name. I'll just see where you are and check it off. And then if you present greater than 90%, you get a bonus 1 mark. Or you get audit. If you want to get an audit, you'll get that. Okay, so you need to be 90%. So we'll have 35 lectures in this course. So I think 90% works out to be approximately 30, or is it more than 30? Let me see, 27 and 45, so 32. So yeah, that's about right. 10% would be 3.5. So we'll round that up, round that down to 3. So you have to be here in basically 32 lectures to get that one. You can miss 3. Okay, that's the first break. In the second break, I usually tell a story. Okay, I have a list of stories. You can go to my website, and these are all stories with a moral. And again, students tell me that they like the breaks and they like the stories. You know, they can't remember anything about computer networking, but they remember the stories. And so, well, you know, I enjoy telling stories, and hopefully you'll enjoy listening to them. If you really don't like them, you can always leave, and there's a Tim Hortons, and you can come back and you can get some coffee. You can miss the story. Many of the stories are on my website, and I'll start with one story today in the second break, so you can get a taste of what it is. Okay, I think that's all I wanted to say about breaks and attendance. Any questions about this so far? All right, so that's the mathematical foundation of instruction. Okay. The other thing I'm going to use is, I'm going to use chalk, and I have white. I also have colored chalk, which I didn't bring in today, but I have colored chalk, so it's high tech. I don't use overheads, I don't use data projectors, and I don't use laptops. Not because I don't know how to use them, but actually I do know how to use them. I've even used them in the past. I found them to be not very good. I found that when you have data projectors, you know, and the PowerPoint slides, 2 things happen. On the instructor's part, you are tempted to push out material faster than students can absorb them, right? There's a rate at which your brain can process symbols and information, right? And that rate is not very high. You can actually probably learn about 3 concepts in an hour, not much more than that. But with PowerPoint, I can push out 300 concepts an hour, okay? And so you're tempted to do that. You're tempted to make these PowerPoints with lots of information in it, and you say, oh good, you know, I'm so smart, I can make this PowerPoint, and you put it up. But the people on the other side, which is you guys, you don't get it, you know, and you can't get it. And so I want to avoid that. Every single thing I write on the board is being written, you know, at a rate that if I can write it, you can write it down too, right? Because it's matched system, right? My writing speed is not going to be faster than your writing speed, okay? Because I'm writing large and on a board. So that's one thing. The other part with PowerPoint is that it puts people to sleep, okay? So I was a terrible student. I studied in a university where many classes were held after lunchtime. And after 20 minutes, I was not even zoned out. I was actually sleeping. It was terrible. One of the worst situations was I was in graduate school and I was taking a course in compiler design from this instructor. I don't know why I took that course because I didn't need it. I was auditing the course. It was after lunch and I kept falling asleep, you know, and every once in a while I kept, oh my God, block synchronization, whatever that is. barrier synchronization, and then I'll just sleep again. So many years later, I went back to interview at the same university, and to my horror, the head of the interview committee was this guy. And a seminar class, there were only 10 people sitting around a table. And of course, he recognized me. And he was very polite and said, "Oh my gosh, I used to sleep in your class," and he didn't say anything. I didn't get the job. So my belief is that if you have PowerPoint slides, it puts people to sleep. So that's the other reason I don't use PowerPoint slides. I use chalkboard instead. So if you do sleep, the other reason for using chalk is that they make very effective projectiles. You can't throw PowerPoint slides at people, but you can throw chalk at people. But I used to do that. And I was warned that this constitutes physical assault, and I could be taken to jail for this. And even if I had tenure, I would lose tenure, I would be put into jail, so I don't want to do it anymore. So I found a better way of doing it. So for the purpose of example, let's pick somebody who might sleep. So let's say over there, I know one student's name at least, so there's Raymond over there. If he falls asleep, what will happen is that I'll just stop and I'll just look at him, and everybody will actually look where I'm looking. It's human psychology. And suddenly his neighbor will nudge him and wake up. He wakes up, he'll find 40 people all looking at him. And at this point, he will realize to his shock that he has become the object of attention of the class, and he will not sleep again. Alternatively, he'll drop the class. Either way, he won't sleep in class anymore, okay? Because he won't be here. Unfortunately, he's my student, so he can't drop the class. But I don't expect him to sleep. It's early in the morning. But so I don't throw chalks anymore. But that's a third reason for using chalk instead of PowerPoint. You can throw it at people. Okay, we're going to have videotape this class over here. There's a nice person there who's videotaping me. And what's going to happen is that in a day or so, I'll get the video in some reasonable format, I think MP4 or something like that. And I'll just put it on my website. If I can find a volunteer, we can put it on YouTube. This YouTube has a U Waterloo channel, I believe, and you can upload it. So if I have anybody wants to volunteer, come to me after class, and I can give you the CD where they put this thing on, and you get somebody can upload it, and then you can watch it. These videos are publicly available. The videos from the previous course are also publicly available on my website. If you just go to my website, you can see it, and each video is about 1 gigabyte or so, about an hour and little bit more than an hour and 20 minutes, and all the other topics are there, and people seem to watch it, so yeah, so you can watch it as well. It will typically take a couple of days for me to get the video, and then usually upload it right away, so it should be a problem. Okay, any questions? That answers your question, I guess. Yeah. Any other questions? But yeah. Okay. So at least that part is high tech. Okay. One more high tech thing, and that's the system called Piazza. So I will not be using ACE. ACE is the system for course management that we use over here, or ACE was the system. It got changed to something called Desire to Learn. But there's a new system out there called Piazza. If you go to piazza.com, that's the website. And if you search for University of Waterloo and CS 798, you will find it very quickly, and you can sign up for being a student. This is a question answering system. And what it allows people to do is to ask questions either using their real name or anonymously. And then answers to be given by other students or me. Okay, and the answers are available sort of right away, so it's like an online system, but it's also a discussion and bulletin board system, and I can post notes, I can post assignments, and I can post solutions. Everything can be done in that system, and it's really nice. It's very intuitive, very easy to use. I actually started using it only last Thursday, so I saw a demo about it on Wednesday, and I was convinced, and by Thursday I started using it. And I set up the course and set up everything. It only took me a few minutes to do it, so it's really quite impressive. And it's being used at a number of universities, mostly in North America. It's being used at MIT and Stanford and Berkeley In Cornell, all courses are are using Piazza, and this is very new. It just started out about less than 2 years ago, I believe. So it's, but you'll see why it's so nice to use. So this is the sort of the official course website. So the syllabus and all the homework assignments and its or problem sets and so on, which I'll explain to you in a minute, will be there. Plus, it has the ability for you to ask questions and also answer them. And you can feel free to answer questions. There's no reason why you can't answer questions that come up. There's a chair over there. Actually, there are 2 chairs over there in the back if you'd like to find a place to sit to be more convenient for you. All right, so the Piazza system is, I should add this, the Piazza system is based in the US, and generally speaking, we are not supposed to use systems whose data is kept in the US because of privacy concerns. However, University of Waterloo has agreed that this is okay. And second, if you don't want to, you don't need to give Piazza your real name or your official email. You can use a Gmail address or some random email address, and you can use, you don't have to give it your official real name either. So if you're concerned about privacy, that's the only thing that they have is your name and your email. That's all they have. And of course, what content you post, but that content is associated with the name that you give it. So if you choose to use a name which is not your official name, just tell me what your name is after class, you know, what name you plan to use for Piazza, and then at least I can see who it is, because I'm going to delete random people if your names don't match. So just let me know, oh, I call myself, you know, Astro Boy on Piazza, and you know, okay, so I'll say Astro Boy is really so and so, and then that will work. Okay, any questions about that? Piazza? Okay. I think some of you already started using Piazza. I saw 7 or 8 people that signed up. Who's signed up for this already? Okay, so do you have any trouble using it? No? Okay. All right. Okay, so it's supposed to be time for the break, by the way, but everything I'm doing is sort of break stuff. Oh, I should explain what I mean by the break also. So actually I'll start teaching in the first 20 minutes, and then all the administrative stuff happens in the break. So if you come in and, you know, normally you start a class with all the administrative stuff. Well, that won't happen here, that will happen in the break. Okay, so this is all administrative stuff. Okay, so about grading and marks. So grading. Okay, so here's the first I'm going to I'm going to tell you 2 completely opposite things. Okay, and it's all based on your psychology. Okay, the 2 opposite things. The first thing I'm going to tell you is that grading in this class is going to be very difficult. Okay, and the second thing I'm going to tell you is that the grading in this class doesn't matter. Okay, so how can these both be true at the same time? It actually can be true at the same time. So first let me tell you why it's going to be difficult. There will be 35 homework assignments. And some of you will notice that there is a very interesting coincidence here between 35 lectures and 35 homework assignments, and it's not a coincidence. There will be 1 homework problem set per lecture, and the problem set will be for the material to be covered in the next lecture. Okay, so problem set 1 is on Piazza already, and that's for Wednesday's lecture. And then on Wednesday you'll have problem set 2 that will be for Friday's lecture. Why? Okay, why am I doing this way? Because shouldn't it be tested on stuff that you learned rather than stuff you already don't know? I mean, it doesn't make sense. And it actually makes sense, and the reason is because there's something called the power of ignorance. Okay, so power of ignorance basically is the fact that you learn best when you know what you don't know. So okay, we'll try this experiment here. It works every time. So are you going to drop the class or are you going to stay awake? Okay. Don't worry, there will be other people also be victims in this class today, believe it or not, even though it's only 9:30 in the morning. Okay, so the power of ignorance basically says, as I said, that You learn best when you know what you don't know. So suppose I ask you to attend a lecture and I say, it's a lecture about some random stuff, but you don't know what you're supposed to learn in that lecture, okay? You just go there, you don't know what you're supposed to learn. Instead, I'm going to give you a problem set. I'm going to say, okay, you're supposed to know this, this, and this concept. And if you try doing it, you'll find that you will actually be able to learn from that lecture a lot better because you're actually listening for it. Okay, it's the same thing when you're reading a paper. When you're reading a paper because somebody said, okay, read this paper, it's different from somebody says, read this paper in order to extract 4 things from it. These are the 4 things you need to know, what is the methodology, what were the assumptions, what was the results. If I ask you those questions, you'll actually read the paper differently. So I want to harness the power of ignorance. And I do that by having these homework assignments, which are actually very simple. And they should not take very much time at all. Like they're all numerical. There'll be 3 or 4 questions. And they'll be really, really simple. So if you read the text and you look at the solved examples in the text, and the text has about 1 solved example per page, so there's lots of them, the questions are based directly on the text. So if you read the text and you read the solved example, you pretty much know what the answer is. Okay, it's just using some terms that you may not have heard about, but once you see what it is, it'll be really easy. And this will be for 1 mark each. And that gives you 35 points, okay, for 35 of these assignments. And if you run into trouble, you can't understand something, you can go to PS and ask a question. Okay, what you're not supposed to do is give somebody, this is the answer, okay, don't do that. But if somebody has a conceptual problem, if you have a conceptual problem, just ask it. You can ask it either before the lecture, and then in the lecture, I'll actually solve all the questions. So all the 35 homework assignments, I'll solve in class. Okay, so you will actually see the numerical question and actually solve it. So so you get the answer in class. How does it get marked? The way it gets marked is that when you come into class, you should bring the solution with you. Okay, and you can write on a sheet of paper, or you can get these index cards. Okay, these index cards you can buy at any store. You can get about 100 of them for $1. So each costs 1 cent. So the cost of course materials for this course is 35 cents, which is not a heck of a lot. So if you get these cards, just put your name at the top and then put down the answer. It will be 3 or 4. And answer number 1 is this number, answer 2 is this number, 3 and 4, etc. And so bring it into class. And in class, when you come in, give it to some random person sitting around you. Okay, so just give it to somebody sitting around you and exchange it with them. Now I understand that you could always give it to your friend sitting next to you, and the 2 of you could be collaborating on and grading each other to be correct all the time. And in a minute I'll explain why I don't care. But just do that. And at the end, when you're leaving class, just drop it off over here somewhere. Drop these cards off on the sheet of paper with your name and with your friend's name. Just drop it off over here, and then we'll enter it into the system, and you'll get some number of points. So if you get 3 out of 4 correct, you'll get 0.75 marks. Okay, it's a rational number. Okay, so it's guaranteed to be a rational number at least. It may not be. It won't be transcendental. Okay, that's the homework assignments, and then there'll be 30 marks for a midterm and 35 for a final. Okay, midterm and final will be sort of standard midterms and finals, which means they'll be closed book and they'll be held at an appropriate time, and the final will be in a normal final in the gym and so on. And the midterm will cover the first half of the course, the final will cover the second half of the course, and so that's the final won't be on all the material, just on the second half of the course. Yeah, nothing special about that. So that's the grading. So next on Wednesday, you should be coming in with your solutions for the class, right? And you should handing them in to your neighbors, and then you should be grading them as they solve the examples and then giving it in and so on. Okay, any questions about this? Yeah.
What happens if you have to miss the lecture?
You don't get that point. Yeah, it's only 1 point. So now the second part, which is why it doesn't matter. Okay. The last time I taught this class, this is how the grading went. The week of the final, you sent me email with the grade that you wanted. 96 or 92, 90, 85, whatever you wanted. You just send me email. I put that on the. I put it on my official report and turned it in. That was the grading. Why? Because the grade doesn't really matter. So you're in grad school, CS 798, 700 level course on a 400 level course. After this, you're not going to be judged on your marks. When you get a master's degree or a PhD, nobody's going to look at your marks. They're going to look at your letters of recommendation, what publications you have, things like that. So if you get a 0 or a 50 or a 80 or a 90, 95, it doesn't matter. Okay, I've been interviewing people for 20 plus years, PhDs, professors. I used to run a couple of companies. I hired, bachelor students, masters, PhDs, whatever. I've never looked at their grades. I never had to. After a bachelor's degree, yes, I need to look at grades. But after a master's degree, never looked at grades. Plus, every grad student gets 80 marks anyway, just for being alive. Okay, in this university, if you're alive, you'll get 80. Because if you don't get 80, you're going to be thrown out of grad school, and we don't want that to happen because, we like you so much. Our funding depends on your being here. So we won't give you less than 80. If I give anybody less than 80, I have to explain to the chair of my department why you got less than 80. Okay, I don't want to do that. So we don't give you less than 80. So between 80 and 100, the dynamic range is pretty small. It's only 20 points. Okay. So if you're absolutely stupid and horrible, well, you wouldn't be coming to Waterloo anyway. So you're not absolutely stupid and horrible. If you're just lazy, you'll get 80. And if you're really smart, you'll get 100. And the dynamic range is fairly narrow. So most people will get between 85 and 94. Okay. So that's why I said just send me a number between 85 or 80 and 100. And I've been doing this for some years now, and only 2 people asked me for 100. Okay, though I said anybody can ask me 100 because it's self-evaluate. Give me a number. Only 2 people asked me 100 in the last 15 years. Most people ask me for 94, and some people are so worried. They say, "What would be the mark you would give me had I actually been getting marked?" So this reverse kind of thing. Do I really deserve to get a 97? Though I'm asking you for 97. And my answer was, I don't care. So these marks don't matter. So if you miss a lecture, fine, you lose a mark, big deal. Okay. So why am I doing this? Why do all these homework assignments and midterm and final? Because of 2 reasons. The first is most of you just started getting, so how many of you, this is your first term as a grad student, please raise your hand. Yeah, most of you are still on this treadmill, like rat running on this little treadmill, and you don't know when to get off. So you're still running. You don't need to run. So I'm going to harness the power of your running on the treadmill to think that you really care about your marks and to do some work. Okay, so that's the main thing. It's like, not that professors are any different. After getting tenure, professors still continue to work hard. They don't need to. Just, I got tenure, I don't know when, I lost track. And I still work hard, though I don't need to because because I'm on the same treadmill. So the university is harnessing my inertia, so to speak. Body in motion continues to be in motion. So yeah, you guys are going to pretend you think that these marks make a difference. You're going to work on this because your brain is still brainwashed. The rest of you who are in grad school for a few years will realize that this is not a motivation. But now here comes the second motivation. The only way to learn math is by doing. So to learn math, you need to do 4 things. In my opinion, and actually many other people's opinion as well. So learning math requires 4 things. One is intuition. Okay. If you don't have intuition, you don't really get it. Somebody tells you some, if I tell you it's an eigenvalue, ax is lambda x, what does it mean? This is nothing. Ax is lambda x is just symbols. Without intuition, you won't get anything. And the problem with most mathematical textbooks is there's no intuition. It just says Ax is lambda x, and you don't get it. So I'm going to explain the intuition. The second part is the actual mathematical notation. Okay, you need to understand the notation, otherwise you cannot go beyond just elementary things. So you understand the actual formal mathematical notation. The third thing is numerical examples. By numerical examples, I mean things where you have numbers. You actually have some numbers.